Hi and welcome. We're going to go over the problem power 3 today. So let's get started. So the problem is given an integer and return true if it is a power of 3, otherwise return false. So if we want to go about starting this problem, we can um, apply the umpire process. So we want to understand the problem first. So to understand the problem, we need to know what the inputs are. The input is an integer n, and then the output. The output is true if power of 3, false otherwise. So let's take a look at some of the examples here to get a better understanding. So if n is 27, 27 is 3 to the power of 3, so that's a power of 3, so it's true. And if n is equal to 0, there's no x to which 3 of it to the x power is equal to 0, so the output is false. And if we have negative numbers, the answer is also false because there's no power of x to which 3 to the x is equal to -1. So we want now that we have understanding of what we're looking for, we can match this problem. So what's a match of this problem? The similar problems are like factorial problems where we um, divide by 10. And here in this case, we want to divide by 3 and check divisibility by 3. And so that's just one way. So that usually leads to the O log n solution, but there's an O1 solution, um, which requires using modular arithmetic to find um, the modulus of the number n um, over the largest power of 3 within the given range of n. And so um, we can also say that a match for this problem to simplify the expression in which we do our checks is modular arithmetic, the use of modular arithmetic. So we want to use selection statements in this case. So now that we have a match for our problem, we want to go ahead and take a look at the plan. So the plan is to check for cases less than or equal to 0, return false, and then check in mod 3 equals 0. Um, so we'll write while n is doesn't equal to 1. Uh, so that's when we divide out by n until we reach the last factor of n, which is 1. So in fact, when n doesn't equal 1, we check in mod 3 equals 0 or not, and reduce n by 3, or divide n by 3, and return n. So we check that, and then we keep on going through the while loop unless and we have the else case, or else we return false when n mod 3 doesn't equal 0. And if the while loop exits, we return true. So let's go ahead and implement this plan. So we want if n is less than or equal to 0, return false. And then if n doesn't equals 1, if n mod 3 equals 0, then n equals n divided by 3, and then else we return false, and then after everything is done, we return true. If in case we have a factor of 3. So we want to check the solution. So it's accepted, and we check the longer submission, and it's accepted. So this is a solution for this problem description, power 3. So let's just skip the review for now and go to the evaluation. We want to review a different problem, or a different solution. So the evaluation is O log n, or O log base 3 of n time complexity, primarily because we divide by 3 each time, and that only takes up a log n of space, or log n of time to go through this iteration of the while loop. And then we have O1 space complexity, since we use this n factor and we don't add any more auxiliary space. And so we want to see an O1 time complexity solution. So how do we go about doing this? So just to give a little bit of intuition. So, well, let's just go over the big picture of this first. So here's the constraint, n is less than or equal to 2 to the 31st minus 1. So we want to be able to find, to figure out if n is a factor of 3, we want the next biggest number above greater than 2 to the 31st. That is a power of 3. So that's going to be, in this case, just knowing the answer, that is going to be 3 to the 19th power. And so if we take 3 to the 9th, so if we take 3 to the 19th power and see if n is divisible by 3 to the 19th power, then this is it's a condition that checks whether n is a divisor of 3. So if we go into the intuition of this, if we just check, say if we have the numbers 1 through 26, and we have n is equal to be in this range, then we want to find the next biggest n, or next biggest x, find x larger, greater than or equal to 26, such that it is a power of 3. And then if we divide x by n, we'll see that for example, x divided by uh, by 2 would not be a power of 3 because x is a power of 3, and so it only has factors of 3. So if you divide by 2, it's not going to be a, a multiple. And then if you divide x by 3, where x is a power of 3, it's going to divide through, and it's going to be a number that's an integer. So we will see that's the condition that if we take x mod n equals 0 checks to see if n is a power of 3. So in this case, n equals x equals, in this case, so let's write up a solution for this. So let's write up a different solution. So we're going to delete this. And then we're going to say if they're not 3 to the power of 19 mod n equals 0, then return true, and then else return false. So let's see if this runs. So it's accepted, and the solution is accepted. So the solution is accepted. So let's review this solution. It's an O1 space complexity and an O1 time complexity solution. So let's check to see like what's going on here. So we want to print this power 3 function, and so our n is 27, and so it's not negative, so it skips the first conditional, and then it checks this conditional of 3 to the 19th power is mod n is equal to 0. And it checks to be true, so we return the value, and it just finishes like that. So it's a very short program, and it's of O1 time complexity and space complexity. So that wraps it up for this problem sets solution. So thanks for watching.